Yes, would you like to? Maybe theorems.
So the theorem, like if there's an arc and we join the radius and the center with that arc, then the angle formed will be twice that of the angle that we will form when we connect those 2 points to the circumference of the circle, any point on that.
Right. Yes, that is a very crucial theorem. So maybe theorems, I don't know, theorems on circles and cyclic quadrilaterals, but so this is also a result that we had discussed. Maybe I had asked to try it. Yeah, let's do this. So if this angle is just writing general theta, okay. So show ACB is theta by 2. Okay. So how do we do it? Any one of you have thought about this?
Yes, sir. I learned the proof as well.
So you can present.
Sir, so if we extend C, passing through O to some point, like extend CO.
Right.
So like extend it a little more, like furthermore.
Right.
So then we can say that AO equals to OC.
AO equals to OC.
Because
Yes.
they are the radius of the circle.
Yes.
So because it's an isosceles triangle, angle OAC equals to angle OCA.
Right.
Yeah. So then angle AO.
Go on.
So can you make the point like OC is extend to some point D, like something.
Oh, you mean on the circle here?
No, sir, not on the circle.
Then just this side? Or?
No, sir. OC is extended to some point. Like it can be on the circle, okay.
Okay, it doesn't matter, you're saying. Okay.
So AOD is the exterior angle of triangle AOC.
That's a nice. Right. So then AOD.
So it will be the sum of angle OAC and OCA.
Right. This is nice.
And similarly, if you take the triangle OCB, you will get it as twice of angle OCB. DOB is equal to twice of angle OCB.
Right. This is nice, right? Okay. Yeah. So then angle at the center is twice. In fact, we learn a little bit, maybe a little bit more, right? That how should we say? I mean, it's all in some way very easy, but it's nice to notice that this angle is X and this angle is twice of that. So that's a little more. Obviously, the elegant thing is the theorem is that this is AOB is double of ACB. Okay? Right. Good. Maybe we can try to do a variant of this. This is a standard result. So Nagesh, is this fine? This is a standard result. We are just kind of, we want to have this in our toolkit.
Yeah, yes.
Okay. This is okay. But let's try to maybe twist it a little bit and see if the following is true. So I don't know if what it will be, but this is the question that I have. So let us say this is A, B, C. This is theta. This is theta by 2. And AB is equal to BC. This is B the center of ADC. So ADC, you'll have a circle around ADC, a unique circle. Is B going to be its center?
Yes.
Yes.
Okay. Why?
Sir, I think the converse of this theorem is also there. I read it, I think.
Okay. But if you can think of a explanation.
So it has to be the center only because otherwise AB won't be equal to BC.
Why? Yeah, okay, I agree. Maybe so if AB is not equal to BC, then it is certainly not the center. But if AB is equal to BC, does that guarantee that it's the center? See, if it is not the center, then AB will not be equal to BC. That I don't agree, because yeah, just AB equal to BC doesn't mean that the third point, that doesn't mean it's a center, right? For example, if you take a circle and you take some center, minute, and then you take this point, which is just on this. So this is the center. Then you see if you take this and this, these two are also equal, but that doesn't mean that this D is a center. Just that does not mean, right? So Nagesh, you have a
Should also be equal to BD. AB equal to BC equal to BD.
yes. So this question is the same. I'm basically asking, is AB equal to BD? Yes, that is the same question, is it? If you can show that, then everybody sees that's the same question. Now, in a way, we have also done this problem when we were doing something like this. If you have this angle, some angle. Now, if there is a point such that this angle is same as this angle with the same base, right? Then then this point has to also be on the circle. We had proved that. This question is like that, but let's do it. Yeah, officially, I think this is a theorem, but it's sometimes not put in this way, or maybe depends on the source. Any ideas?
Sir, if AB is not equal to BD, then the proof I just told will not work, right? Then we won't have those isosceles triangle. So then we cannot say that the angles are equal.
I agree, but there may be some other way to prove it. Right?
So can we assume AD is equal to BC?
AB is equal to BC.
No, AD is equal to BC.
Let's say, so what do you get if you assume? In gen, that I have not given that. But okay, I mean, do you get any ideas if you assume that AD equal to DC?
We can prove that triangle ABD and DBC are congruent.
Okay, so that I will congruent. Why?
All three sides are equal.
So you said ABD is congruent to what?
CBD.
Yes, I am convinced. Are others convinced? Right? She gave a nice explanation. Just all the sides are equal. So, right? In the right order, AB is equal to CB, right? And similarly, yeah, BD is equal to BD. So, so then Ishana, in this case, do you get that D is on the circle?
Sir,
So-
but through this we won't be able to prove that BD equals to AB or BC, right?
I don't know. Maybe or maybe not. Can we? Maybe we can. Let's see. I Also, so now in this class there we will be going like I will not be saying much, okay, because I want you guys to say more and want this to move faster. Okay, so and this batch, so I've kind of separate the other two people, they will be in the other batch, and you three will be in this and Sunday. Okay, so I want this to take this. I know, yeah. So now means that you'll have to take more responsibility of main thing is clarifying doubts and so on. Okay, means if you don't get, you have to ask. Okay, then we'll move more serious pace. So then can we prove from AB equal to BD? Draw a picture in this way, maybe then you can see. Situation is completely symmetric. That is about the vertical line. Answer is yes, we can say, at least I'm able to say. Use the symmetry, it's completely symmetric. Try to use the angle that is theta by 2. If you use symmetry, then what happens to the angles? Do the calculations.
Sir,
Yes.
sir, if we join BD
Hmm.
and if we name ADP and BDC as X and uh, DAB and DCP as Y, like the three angles, equal angles.
Okay. Yeah. X. So this is theta by 4. Call it X. Okay.
Sir, then can we say that 2x equals to theta by 2?
Yes. Right. That's
And
it.
2 of x plus y equals to theta.
Yes. 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 That's easy. Yeah. You're right. Idea is through. Correct. Everybody can see, right? I mean, if this is theta by 2, that this angle is theta by 2, then this angle is also theta by 4, right? Because then only it will add up theta by 2. Again, so Aparna earlier gave this argument, right, about internal angles equal to the external opposite angle. So this is also that same argument, right? So that has to be also theta by 4 and AB equal to BD. So this case is fine. And if it's not fine, then you should say. Now, the second case is when AD is not equal to DC. So at least we know that in the case of complete symmetry, this point D has to be on the circle. So in a way, it is like fixing the point B when you make the circle, right? Then that circle, that point D is on the circle if it's isosceles. So at least you can't change heights in that way. You have to be on the circle. What if D is not on the circle? You can think of it like that, right? What if D is not on the circle? See, this is the thing. You want to prove that a point is on the circle, right? Then natural way is if D is not on the circle. You already know that for any point which is on the circle, this is theta by 2. That you know, we have proved that. If it is on the circle, then it is theta by 2. Okay. So if D is not on the circle, then what do you do? So we do the same thing as we did last time, is we use the fact that, if it's on the circle, then it is true. So we go to the nearest such point, right? We physically extend this, right? So we can forget this, right? And this is what we were doing last time also. This has to be theta by 2. That is, we already know, because it's on the circle. And then you can see, can these two things both be theta by 2? No, right? That has nothing to do with circle or anything. It is not possible. Two things like this cannot be theta by 2. So you can write from one point, line, for a given angle, you can draw a unique line. Any doubts? Okay, all good. Right. See, you have to, if there is even a bit of doubt, you should say, okay? So that, because these are the beginning stages of circle geometry, and it's clear then it is. So any other theorems in circle geometry that has, that you, that is there?
Sir, I had seen that if the opposite angles are supplementary, then it's a cyclic quadrilateral.
Yes. Let us prove it. So first, one question I will ask is, do we know that if it is a cyclic quadrilateral, and this, that was also one of the homeworks I had given, right? But this one we had done in class, this version, that if it is a cyclic quadrilateral, then so as the picture is saying, it's a cyclic quadrilateral. Do we know that angle ABC plus ADC is, so they are supplementary, so they add up to be 180 degrees. Is that something that I'm sure some of you would know, one of you at least, so you can tell the proof, then we'll move to the converse.
Sir, I know the proof.
Yes, so you please say.
Sir, if we connect the center to A and C,
Okay.
and we use the same property we just proved, then angle AOC will be equal to, so the
Yeah.
obtuse one will be equal to 2 times CDA, and the acute one will be 2 times, okay, the reflex one will be 2 times ADC, and the obtuse one will be 2 times ABC.
Okay, right.
So 2
That's
times, the two angles will be 360, so x plus y will be 180.
that's a very nice argument. It's a very elegant argument, right? And that is a cool argument. Right. Now we basically want to prove the converse, right? If it's given to be 180 degree, show ABCD is cyclic. So these are your ways to prove things are cyclic. The converse nobody knows or has seen the proof. that have thought about it? How many of you have thought about it? Okay, maybe that's a vague question. So yeah, leave it. Hmm? So the strategy will be, again, you want to show 4 points are there and you want to show there is a circle passing through them, right? So you take 3 of the points and you make a circle, right? So there's only one circle you can make. Now you make that circle. You want to show that the fourth point also passes through the circle. There can only be one circle. So you don't have to think so much, right? One circle, let's say I take that circle passing through these 3 points. Now I want to show that the fourth one also passes through that same circle. This is like the only thing in sense. So assume it does not pass, right? Assume that in this picture that C is not on the circle, just like we did last one. There is conceptually there is not much difference, right? Assume, so it's just writing, it's already there in the picture. C is not on the circle. So you understand what the circle means. Yeah, the circle that passes through A, B, and D. Yeah? Then what do we do? You
Sir,
know,
but
yes, yes,
BCD plus BA, BCD plus BAD is 180.
right.
So it has to be a cyclic quadrant.
Why?
Sir, because the theorem we just proved, the opposite angles of a cyclic quadrilateral are always perpendicular.
Yes. So we proved that if it is a cyclic quadrilateral, then the opposite angles are 180 degrees. Right? Right? But that is not this, right? It means if you say it again, you will understand yourself, right? If we proved ABCD is cyclic, implies opposite angles are 180 degrees. But in this statement, nowhere do we say that if the opposite angles are cyclic, then ABC, if the opposite angles are 180 degree, adding up to 180 degree, then it is cyclic. That is a different statement. Do you see the difference?
Yes.
There are two different things, right? Yeah. So if A happens, then B happens. But that doesn't mean that if B happens, then A must happen necessarily. In some cases, and you will get a sense of when it should happen and it should not happen. Those are the different things that will come through the maturity of the nature of the subject and nature of the topic, and a lot of things are there. But logically, you must understand the difference, right? Like if a number is positive, then its square is positive. But it doesn't mean that if the square is positive, the number must have been positive. It does not, right? negative number square will also be positive. Otherwise, there is nothing to prove. So think of some idea, and maybe if for a second, maybe you can just try to mimic what we did. Even maybe like without completely knowing if it will work, you can just try to mimic. Right? C is not on the circle. You know that if there was a point on the circle like this, you know that then this would be adding up to 180 degree. That you know. Can you use that? So we are right. We know that okay, less than 1 minute is for any E on the circle ABED, right? This will imply the supplementary thing. So, well, we do the same thing, right? We just extend this because that's the easiest way to use the thing. See, you have to extend it so that it's the easiest extension, right? So that you can use the theorem that you have. So you know that this plus this is 180 degree, right? So this is x is 180 minus x. And then you understand, right? But then we are given that this is also 180 minus x. So they have to be the same points, right? Right, this C prime and C have to be the same points. It is the same thing. There's no difference.